Hello, this is a Connect team. In CAP Tutorial 1, we introduced how to create a cap using the cap mold and visor from Connect. In this video, we'll take it a step further by sharing practical tips that can be applied in your production process. Let's start by loading the cap asset. Open the CLO library and go to the Garment category and navigate to the Connect Asset tab. In the search bar, type Mid-Profile. You'll now see both male and female cap assets in the library window. These assets feature a standard 6-panel cap design with a fully constructed snapback. They're built using the mid-profile cap mold and half-curved visor, so if you want to match the same silhouette, make sure to use the same mold and visor types. Now, let's double-click on the male version to load it into the workspace. Next, let's load the cap mold and visor. Go to the Avatar tab in the CLO library, navigate Connect Asset tab. Search for Mid-Profile Mold and Half-Curved Visor. Load each item into the CLO. When loading these files, make sure to click the Add option. If you don't, the current avatar will be replaced, and your existing work may be lost. Once the visor is loaded, adjust its angle to align properly with the cap. Then, select both the mold and visor and set their skin offset to 0. Now, let's move on to creating the details of the cap. We'll start by adding a bias tape. Since the process of creating and attaching bias tape was covered in detail in Tutorial 1, we'll go through this step quickly. If you'd like a more in-depth explanation, please refer to the Tutorial 1 video. Next, let's create the back opening bias tape. This process is also covered in Tutorial 1, but in this video, we'll take you from understanding the process to applying it in practice. For designs with a back opening, such as this asset, the bias tape will be rolled and sewn together with the seam allowance when making the actual construction. In this case, the outline length of the back opening with seam allowance will be shorter than the outline length of the pattern without seam allowance. Then, when the seam is rolled with bias tape, the final length of the back opening ends up being the same as the length of the seam outline. This process gives the back opening a neat, rounded shape. However, since CLO uses patterns without seam allowance by default, it's difficult to simulate the rolled sewing process accurately. So in this video, we'll walk you through how to predict the final length of the back opening and create the bias tape accordingly. A method that closely resembles the actual production process. First, let's create a seam, just like in the real production. Right-click on the back opening segment and select Extend Pattern Outline. Then a dialog window will appear. In this case, we'll input 0.25 inches for the seam width. Now that the seam allowance has been created, click on its outer edge to check the outline length. You can check the length at this point. Next, let's create a bias tape pattern based on that length. Select the rectangle tool, click on an empty area in the 2D pattern window, and enter the dimensions in the dialog window. Set the width to the outline length you just measured and the height to the seam width, which is 0.25 inches. Once the bias tape is created, we'll need it on both sides. Right-click on the center line and select Unfold Symmetric Editing with Sewing. Now we no longer need the seam allowance pattern we created earlier. Use the Trace tool, right-click on the baseline, and select Cut to remove it. Finally, let's create an internal line where the bias tape will be sewn. Right-click on the back opening outline again and select Offset as Internal Line. In the dialog window, enter 0.25 inches, which is the width of the bias tape, and click OK. Now let's move on to sewing the bias tape. Before we do that, let's understand how this process works in actual production. In actual sewing, when bias tape is applied along a curved area, it tends to follow the shorter seam line, which causes the final length to shrink slightly. On the other hand, for straight areas, such as the bottom edge, there's little to no change in length even after the tape is sewn. Also, in areas where the bias tape is sewn in multiple layers, the fabric becomes thickly stacked. As a result, there is little to no change in length. Therefore, in CLO as well, we will sew the bias tape at a 1:1 ratio along the straight bottom edge and in the layered section where the tape is attached. Now let's use the free sewing tool to sew the bias tape to the back opening. Start by clicking and dragging along the back opening from the bottom edge up to the point where the curve begins. If you're unsure how much of the section to select, simply sew up to the height of the snap as a reference. After clicking the starting point, right-click and enter the desired length in the dialog window. Repeat the same click and drag action on the bias tape pattern and finish sewing by clicking at the snap point. For the remaining parts, also sew with a 1:1 length ratio. Next, sew the upper part in the same way with a 1:1 ratio. Then, select the remaining portion and complete the rest of the sewing. Change the sewing line type to turned. Before running the simulation, select the pattern and lower the particle distance to 5 and set the collision thickness to 0. To arrange the pattern, right-click on the tape pattern in the 3D window and select Superimpose Under. You'll see the pattern placed along the sewing line. Finally, apply strengthen to the entire pattern and run the simulation. Now let's create the sweatband and add some realistic detailing. In Tutorial 1, we already covered how to create a basic one-layer sweatband similar to an elastic band, so in this video, we'll focus on making a more realistic double-layer quilted sweatband. By constructing the pattern with 2 layers, we can simulate a more substantial and detailed thickness, just like the real thing. Right-click on the top edge of the sweatband and click Offset Pattern Outline. Set the distance to 1 inch and make sure to check Create Internal Line, so that an internal line is automatically generated as the pattern extends. This line will be used later for folding. You'll now see the extended pattern appear in the 3D window. From the 3D toolbar, select the Fold Arrangement tool and click on the internal line at the center. You'll see red and green gizmos appear. click and drag the appropriate gizmo to fold the pattern in half. Before running the simulation, sew the top and bottom outlines together and change the sewing line type to turned. Then double-check that the particle distance is set to 5 and the collision thickness is 0. Now run the simulation. Once the simulation is complete, let's add stitch lines to simulate the quilted finish. Right-click on the center line of the pattern and select Offset as internal line. In the dialog box, set the number of offsets to 2 and the distance to 0.33 inch. To apply the lines on both sides of the center, check both sides, then click OK. This will generate 2 evenly spaced internal lines at 0.33 inch intervals, perfect for quilting detail. Once the internal lines have been created, sew each line and run the simulation. The number of quilting lines may vary depending on the design. If the simulation becomes unstable due to overlapping pattern layers, use the gizmo to slightly move the visor pattern forward. This will help prevent collision between patterns and ensure a stable simulation. Next, let's add detailing to the visor. In actual hat construction, the visor typically consists of 2 layers of fabric that wrap around a visor pad. To recreate this in CLO, we'll use the layer clone feature to create a double-layered visor. Before that, let's add the stitching lines to the visor. When you use layer clone on a pattern with internal lines, CLO automatically duplicates the pattern and stitches it along those lines, so it's best to add the stitching lines first. Right-click on the outer edge of the visor pattern and select Offset as internal line. In the dialog window, set the number of offsets to 5 to create 5 stitching lines. Then, switch the distance option to individual to define each offset separately. For the first internal line, enter 0.5 inches, as it should sit slightly inward from the edge. For the remaining lines, enter 0.25 inches for each to evenly space them out. Once you've completed the setup, click OK to generate the internal lines. Now let's create a double-layered visor to replicate the real construction where the visor pad is sandwiched between 2 fabric layers. Right-click on the visor pattern and click Layer Clone Under. Then, click on an empty space in the 2D window to place the cloned pattern. You'll see that the internal lines are automatically sewn together with the new layer. To simulate the visor pad thickness, select the top pattern and apply an additional thickness of 3 in the property editor. Adjust the curvature to 20% to give the edge a more angular appearance. By default, the additional thickness collision is set to 0. This can cause the top layer to sink into the bottom layer during simulation. So, increase the additional thickness collision to 3 and use Superimpose Under to correctly place the bottom layer. To maintain the shape of both layers, select the visor patterns, right-click, and apply Solidify. Make sure Freeze is unchecked. Set Strengthen to 80 for a firmer structure and run the simulation. You'll see the visor hold its form more accurately. Next, let's apply Solidify to the crown pieces. In real hats, the front crown panels are reinforced with a stiff interlining to maintain the hat's profile. Reflecting this, apply Solidify 100 to the front crown panel. For the remaining crown panels, apply a Solidify value of 40 to simulate a softer structure. Run the simulation and check the overall shape. If any sewing lines have come undone, especially on the snap pattern where seam allowances were previously created and cut, make sure to resew them to prevent the patterns from detaching. When looking at the visor, you'll notice that the thickness direction is currently set to both, causing the visor pattern to extend above the crown pattern. In this case, if you change the extrusion direction to backward, the thickness surface will be directed downward. In this case, the lower pattern may become hidden due to the overlapping thickness. To resolve this, you can reposition it using the superimpose under function. However, since the upper pattern's thickness now extends downward, you must assign a sufficient collision value to prevent the two patterns from overlapping. To ensure proper placement, it is recommended to set the collision thickness of the lower pattern to 3, matching the thickness of the upper pattern. If you want to add more thickness to the lower pattern, increase the value in the additional thickness rendering. Next, let's add details such as applying fabric, the top stitching, and the top button. These steps are also explained in Tutorial 1, so we'll go through them quickly in this video. Finally, let's import a different type of visor and make changes to it. Connect offers various types of visors, and in this case, we'll work with curved one. Double-click the asset to import it and delete the half-curved visor that was previously imported. Now adjust the angle of the newly loaded visor to the desired angle, and change the skin offset to 0. Now, to ensure smooth simulation, please delete the lower pattern and remove the sewing lines with the crown patterns. Select all crown patterns and freeze them. At the same time, unfreeze and unsolidify the visor. Apply strengthen to the visor and run the simulation. You'll see the pattern naturally simulate to the visor's curvature. To simulate a perfect fit to the visor shape, we apply a negative pressure value. Once the pattern simulates the visor, stop the simulation and apply solidify again. Now, resew the patterns and adjust the fold angle accordingly. And don't forget to reset the pressure back to 0. Let's unstrengthen the visor pattern. For better stability during simulation, slightly adjust the position of the pattern and visor to place them as close to the crown as possible. Now simulate again. Your curved visor is complete. We've covered several methods for accurately constructing cap, reflecting real production processes. Now, try designing your own styles using the various molds and visor types available in Connect.